Okay, hello everybody. Hello. So sorry for the latest. The weekend was crazy. I was supposed to stream on Saturday, and here we are on a Monday night. So we're gonna get to the stuff today. What we're going to do, we're gonna go and take a hack at Gaussian elimination. Pretty classical calculus type of algorithm to solve system of linear equations. And we're also going to try to take a hack, if we have time, if I'm not stuck over there for like 6 hours straight, on AutoGrad. So this is another pretty classical algorithm for deep learning though. Yeah, so that's the two we're going to do. Remember, the point of this live stream is not to do these. It's just like a way for people to come in and then to like start to study and stuff like that. Don't hesitate to ask questions if you have any question related to deep learning, machine learning, career in this stuff, entrepreneurship in the tech space. That sort of stuff I can help with a bit. So a bit about me. Let's put that full screen. So I'm Yassine. I'm a machine learning practitioner. I own a business that is doing like tech AI stuff in the supply chain space, and I have a background in research, neuroscience research to be more precise. So I've been dabbling around AI for a pretty long time. So if you have any question on any of these topics, don't hesitate. And let's actually get to it. Okay, let's go this one first. So Gaussian elimination, implement the Gaussian elimination method. By the way, we're on this on DeepML. It's kind of like my favorite website these days. So you can check it out here. One of the two problem over there. A pretty good website. I absolutely love it. Okay, so implement the Gaussian elimination method. Your task is to implement which transform a system of linear equation into an upper triangular matrix. This method can then be used to solve for the variable using backward substitution. Right. Okay. Partial pivoting to solve the system AX. A is our matrix, right? Coefficient matrix, yes. X is our the thing that we're gonna output, and B is our right hand side vector of value that we need to match with the transformation matrix and X. Okay. Hi, I'm an animation programmer at a game company interested in AI stuff, so studying after work. Really cool stuff. Pretty nice. Animation programmer. What do you do? Like you're like we're talking animating like 3D 3D objects, or like 2D stuff in games, I suppose. Yeah, it's a game company. Seems to be pretty interesting. Don't hesitate if you have any question. Really here to help. Okay, so this is an array. No, it's a matrix 3 by 3. I think it's always going to be square, right? It has to be. Air and cloud programming. Oh shit, 3D. Cool, nice. When I was in university, Langer, McGill, there was this teacher. Yeah, that guy. And he was absolutely bonkers. The guy was insane, and he was doing these sort of he was designing the algorithm to visualize this type of thing. Trying to find his website. Where is it? This one? No. Wait, that thing. Was this guy's Michael Langer? You know, it's a good. Like he's a comp sci teacher when he has like a website like this. So this is what he was working on, like applied perception in graphics, human vision, appearance models, like that type of stuff. He was designing like these type of algorithm and like literally making the algorithm for this. It's pretty cool stuff. It's like very OG type of computer science. The guy is Dr. Michael Langer. If you're interested in checking this out, made me think of him because like look at this. It looked like a guy has been arrested or something. But like pretty interesting stuff here. You can check out his publication. Like he's been publishing forever. Yeah. Cool. So you do air and cloud programming. So what does it actually apply? So you just add like you edit the algorithm, and or like where do you work on, like Blender or some stuff like this? Okay, there's two things here. I have to do transformation and then use backward substitution. Okay, seems to be two-step. So create an upper triangular matrix. So that seems to be step one. And then somewhere I have to do use backward substitution. Okay, cool. Nice, pretty cool. And you're interested in the AI to kind of automate some of your work, or like transition into another type of role. How does it look like for you? Because in gaming, there's a lot of application of AI that are like pretty direct. Okay. So row echelon form, we already did that. We already did the RF algorithm. we had some issue with it, but we managed. And then with row echelon form, then we can do the backwards substitution. So non-zero are above any row of all zeros. The leading entry of each non-zero row is on the right. Yeah, that I know. Yeah, we need to do that. We just need to do the RFF. Wow, this is pretty straightforward, right? So it seems to imply, whoops. So first we need to put it to RF form. Version form. That's the criteria. What's the purpose of implementing these yourself? Interview prep? No, just like a pure training. It depends what you want to do, right? Like if you're trying to gun for a machine learning engineer position, like these are super useful because like it's kind of lead code style question that might happen in the interview process. But anything other than that, like these are good if you're trying to understand deeply the material. I usually don't recommend that, actually. Like if you're trying to learn AI, don't do that. Like don't do this stuff, right? You should go in the opposite direction and try to like make something useful directly, right? There's so many layers of abstraction now with like machine learning and AI that you don't need to start from nothing, like we're in 2010 or something. It's rare that you're gonna need to understand like the crude basics in order to do something useful and something that is worthwhile, right? But at some point you're gonna need to like in order to truly reach some mastery, you're gonna need to go back into the basic and like master these foundations really well. But like this, the purpose of this is really to, I don't know, like have something that everybody can understand, right? Like we have code on the right, we have theory on the left, and it's some very basic stuff. The application of this very limited, unless it's like just for like academic and understanding purposes. If you want to get like truly good at AI, you just need to go and do project that matters to you, right? If you can do that, and then like you can like like waddle a bit around the uncertainty, you're gonna learn so much more, and it will be practically useful much faster. So that's what I recommend everybody. This is just a trap. this live stream is basically just a trap to tell people to not do this. Okay, so for a linear system, AX equal B, an augmented matrix is a way of displaying all the numerical information in a linear system in a single matrix. Let's combine the coefficient matrix A and the vector source B. Oh, this I know. But wait, and this is the augmented matrix. True. And then how big is this? Okay. In linear algebra, this is for the second. No, this is still the same. Okay, in the linear algebra, the diagonal and matrix are referred to as pivot. I know that. Okay. Interchange row, entering a non-zero pivot. Okay. Okay, right. But this is not the same algorithm that I've been doing last time. Apply partial pivoting to the current row. So for I, k plus 1 number of row, what is m? For j equal k. What is it? What are we doing here? How should I get what's I guess that's the whole algorithm, but okay. For k equal number of rows, this is the backward substitution step. Okay, let's solve the system of equations. We have this one, we have b here. We apply partial pivoting to increase the magnitude of the pivot. For A11, calculate the factor for the elimination of A12 here. 0.4. Apply the scaling to row 1. Right, and then we delete the other one down. Yeah, okay, cool. So we'll kill this off and kill also B. And okay, yeah, so this one is killed off. This one is killed off. We have that. And then we go on the next row in over here. So to calculate x, we apply backward substitution by substituting in the current solved value and dividing by the pivot. What are we saying here? Just give the following for the first iteration. X3 equal to B3 3 divided by this one. So we get X3 equal that. Okay, yeah, that makes sense. And then we go, okay, we backward substitute everything on the top. X, like, because we have this one now, we're going to be able to do that one because we're going to do 3.6 times this plus that times something. It could give us 0. Okay. Okay, yeah, cool. Okay, I think I get it. This is not the algorithm that I've saw for which one was it? This one. It's not the one that we used. When we did row echelon form, it's a bit different. We started here, but this is reduced row echelon form. That's what we're trying to do here. So wait a second. We're trying to do that. here, and then we started here, select the pivot row, and then we shifted stuff around. But we don't need to go into reduce row echelon form here. It doesn't matter. We just need to go into row echelon form. Okay. Okay, so if, okay, now that I get it a bit, let's go back here. We have this first. So, yeah, for people wondering like why I'm not coding right now, use this. I only code when I know the solution. I rarely code when I don't actually know what it's already hard enough to debug, right? It's harder to debug when you don't know if you're doing is correct, but if you know this flow is correct, then it's a bit easier. So like I'm trying just to decipher here this formulation. I'm gonna use that. I'm also very visual. Like I need to kind of play around with wait, this is not right. I don't, well, yeah, I need that too. What do I need to? Yeah, I need to make the augmented matrix because I need to concatenate the two. Because like these two will be affected the same. So if like I divide here, that will apply here. So yeah, I'll need to make an augmented matrix. Right, so I think that's the first step. First step. Also do the augmented matrix via concatenation. Okay, so this is kind of here. Backward substitution, we're just gonna put it here for now. And then, yeah, I'll just put it at here. We do that first, right? And then after that, we try to put it into REF. So REF, sorry for that, stand for row echelon form. It's like this, it's this form here, right? This has a row echelon form because it's an upper triangular matrix that has the following characteristic, right? These characteristics. So this is REF. So we start from here, right? Like this. And then we go to that. So here to here. This is an REF. Okay, cool. So for k equal 1 to number of row minus 1, I guess we start at k1. Why are we starting at kit 1? Apply partial pivoting. What is partial pivoting? Pivoting is it to choose rows with a non-zero pivot. Ah, right. Okay, cool. Case pivoting. Wow, it's starting to look like the other algorithm that I've implemented. Right? So here, this is this. We're gonna have to have a mini little algorithm here to do that, which is gonna scan the row. Scan the row in this given column. Right. So Diagonal element of a matrix are referred to as pivot. So in the system, diagonal is used as a divisor for an element. The Gaussian will fail if there is a zero pivot. Okay, just put in, I guess. In this case, pivoting is used to interchange rows, ensuring a non-zero pivot. So non-zero pivot. Specifically, partial pivoting look at all other rows in the current column to find the one row with the highest absolute value. So highest absolute value is important. This row is then interchanged with the current row. This not only increase the numerical stability of the solution, but also reduce run of error caused by dividing by small entries. Nice. We do that. There. But I can't do partial pivoting on something that's already processed. So if a row is processed, I can only do the stuff below. Yeah. Okay. I think I've done something similar last time. So I'm going to be able to reuse that. And then after that, for I in k plus 1 number of row, so everything below that line, I'm going to do mik equal to I at this row in the, what is k? K is this. This is the column, right? Divide by this, this is this thing, and then we're applying this to every one of them that is below. Yeah, it's very similar here. Very similar to that other algorithm. Yeah. So wait, select the pivot row. Yeah, there needs to become kind of like a I guess I can just I just need to bound my search between the index that I'm at. I can just look at the rows from like where I'm at to here, right? And once I'm doing this, I'm gonna go here to here, and then here to here. That's the only thing I can change. And then I don't need to do that. And then this is the same thing as before. Yeah, this is the same formula. Oh yeah, perfect. Okay. I'm just gonna leave myself a note. Only do partial pivoting in rows that are at k and above. Yeah, that's it. So this is not a requirement. Okay, cool. For a, okay, no, that's good. No, yeah. And then we scale. So this part, this whole thing, this is just scaling RF. Okay. For j equal k, number of column, there's no point in like if we start here, okay, they're doing it like row by row. Okay, it doesn't matter. So if we start here, we can we're gonna go like and apply it on the whole thing here, right? But then as we move on, let's say we start here because these were zeroed out, we're gonna apply it to these elements. That's that. It's kind of how it goes, right? And this is element by element. Okay. And then what is up here? Bi equal b. What's a b? Oh yeah, it's our b. This is for the whole row. Okay. So this is the update for the b's. But I guess we don't have to concatenate then. If we're doing it like this, we don't have to. Hey Yassine, thank you for sharing your knowledge with us. I just want to ask, what's the best way anyone can learn basic matrix and get familiar with them? Aha, it's a good question. Mathematic, machine learning. I always recommend that book. Wait a second. This one. Wait. Give me 2 seconds. I just need to pull it up. No, just mathematics for machine learning. Yeah, this one. Okay, this one is solid, right? Like, if you want to get like how to say it, get a good feel of machine learning in general, that's sorry, the mathematics behind machine learning, I think you should go over here, right? So it's the kind of book that yeah, will be in kind of in breadth, and it will tell you where the depth is, right? There's a lot of definition, and there's exercise also that you can do. We've done the exercise over there for a while. We're gonna maybe redo some of them after that, but it's good for you to understand what is useful and what's not for machine learning in general. This is one resource that I highly recommend. You can find the full book over here, right? I bought it because I don't know, it was a good book. Like I read it from time to time, chapter by chapter. This is one, and then the other one that other piece of courses that I think like is super solid is just wait, what is it called? I have a blank. Wait, is this one? Yeah, the Khan Academy ones, right? Honestly, that's all you need. Like I don't like there's not that like much good like other courses that I feel is as battle tested as this. So the Khan Academy ones, you should definitely explore them and then just go through them. It's so much step by step that like there's no way you're not gonna understand a topic, right? There's everything you need over there, plus it's free. So that's another big one. The third one, I haven't tested it, but it's like how's it called? It's like Math Academy, I think, and it seems to be pretty solid. So that's another one that you can check it out to get like pretty good at like calculus stuff. So this one, Math Academy, but I never tested it. This one I'm not sure, and it's paid also. So not sure at all. But if I were you and you wanted to kind of learn the basic metrics, vectors, and all this stuff, you go mathematics for machine learning with the Khan Academy kind of curriculum, free, and then you just do the exercise, right? You just do it, and if you truly want to learn that, you go ahead and you do as many exercises as possible. But if you need something more, you can try this one to learn like all the maths that you need. I heard great thing about this one. Yeah, and always remember, right? Always remember why you're learning this stuff, right? That's the most important point, right? If you're just learning this stuff because you think you have to, it won't work, right? Like a y is truly important. So usually, like especially in machine learning, at some point somewhere you're gonna hit like some deeper mathematic concept that you will not understand, right? And because you require some calculus, some linear algebra. If that's the case, then you go and then you go back to learning the basics a bit more. So yeah, that's what I would recommend. Hope that helps. Okay, so that's good. Okay, yeah, so I think here we're done. If we're doing this, so this we don't need to do at all. Like that stuff, we don't need actually to do that. Yeah, we're out of here because of the don't actually to do that because how algorithm is stated. So that's that. No worries, keep it up, keep learning. That's the most important part. Why am I okay? Yeah, good. So at this point I think we're done with this. Like this algorithm, I think I know how to do it. That's good. And now it's backward substitution, and backward substitution is just like what we're doing on the bees to find our x, right? And just this algorithm over here. So okay, like this. Okay. So for k numbers of row to 1, so okay, so we're going this way, right? Like this, and we're going through that, let's say. So it's mainly this. Like this, right? I don't know why they start at 1. It should be 0. Okay, that you have to be careful here. I'll just take a note. Note in the algorithm below, replace 1 for 0 and num rows / call by num row. Yeah. Have you ever used like a programming language that starts at 1, right? Like a Dix has an index of 1. Like these are usually absolutely garbage programming language. MATLAB is one of them. I hated that thing. Okay, so for k number of row to 1, so we go backward. For I number of columns minus 1 to 1. What are we doing? Ah, wait, right. Okay, I think I get it. So it's at this point, right? Yeah, here. That's a better visual here. Okay, wait. So this is the better visual. I'm gonna put it bigger. I like to honestly I like to do these. Might be weird, but like I like these puzzles, right? Because for me, like these algorithms are like a bit of a puzzle, and like you get to understand a bit the flow, and once you get it, it's nice. So we start here, right? And then what we do is like we're doing all of them. We're always doing all of them like this, right? And what we're doing is like we say bk, and we accumulate that, right, over here, equal to bk, so where we're at, so here it's 3, minus, and then we take like that number first, right? We're doing this number, right? Time b at I. And b at I is what? Oh, that's a bit weird. But does it matter though? No, it doesn't matter because we're at the end. There are zeros here. So this one is using that. This one is using, okay, right? So time bi, and then in this case it will be like, it will be this one also, right? So this, but this is 0, right? And then you're gonna continue. You're gonna remove again the other one here, like this, but like this one also. So you're gonna do bi again, and this one will be this one, but it's still gonna be 0. And here, then you're gonna do this one, and you're gonna do minus 5.4 times 3 here. What the fuck? Cat high. I don't get it. Wait. Okay. So there's pk divided by. I'll need to see. So here. So at the end we're doing this divided by that, yes. But so that means that it means that what? This whole thing is useless. Yeah, I don't get it. Well, what's up here? It's like 3 minus 0 minus 0 minus 514 times 3. For I equal a number of columns, or does it start at 0? No, I don't get it. Because bk, we should, like here, we should have 3 divided by what? Minus 5.4. How do you get that with this? These two are garbage. This is nothing. We start here actually, right? We're doing this plus 5.4 times 3. Then we normalize. Normalize with the pivot. Yeah, that's a pretty important one to get, because if I don't get it, I'm not gonna be able to do the. I don't get the backwards substitution right now. So this is by rows that we're going, the K's, and we start by the end, right? So we start here, and then we're saying bk equal, so be at 3 here, equal 3 minus this times 3. So this, and then we accumulate, right? But what the? So because like here at the, so we're gonna get 3 plus 5.4 times 3, right? And then we're gonna do that whole thing divided by hey, yo, this makes no sense. This doesn't make any sense. Should we start at 0? I don't get it. What is this algorithm? God, this algorithm is not right. Am I dumb? That's highly possible. For I equal number of columns minus 1 to 1. Oh, okay, wait. No, we're not doing this. We're not getting there. Ah, okay, cool. Yeah, here. This, it doesn't include that whole part here. It doesn't include that. It just include like from number of column minus 1 and 1. So these ones. I'm getting thrown off here because like it's the indexing start at 1, which honestly is not that great. Like I don't like when we start at 1 if like the indexing is you think about it, zeros. Okay, so if we go through it, this whole thing is gonna be 0 because we're just accumulating something. So 0 minus that, 0 0 0, and then we're doing sorry, it's gonna be 3 minus nothing nothing divided by this bad boy over there, and then that number bk here is now 3 divided by minus 5.4. Then when we're gonna do that part, the fuck we're gonna do? What are we doing here? Then the second one I don't get. We're gonna do b is we're gonna do 0 minus oh, that part I'm not sure I get. No, I'm not sure I get it. Because the second one, right? If we look at it, right, we have the second one here. We have so this is the second row, right? So this was the third row. The second row we have bk equal, and then we're gonna have what? We're gonna have 0 minus a at 2 at I, which is 6, which is 6 time wait, 6 times 0, I guess, minus, and then we go to 1 here, so it's like what, 0 times whatever, 5. Okay, and then what we do equal 0 divided by, I guess still 0 all across here, 0 divided by 6, so that's 0. That's our bk here. Okay, And the last one will be yeah, I'm not sure I get it here. No, to be honest, I'm not sure I get it. What's up? By substituting the current solved value and dividing by the pivot. This gives the following for the first iteration. We go from back to top. That I get. That makes no sense to me. Yeah, this one I don't. Anybody, if you have any, let's get some perspective. Backward substitution method. Substitution. Come on. Okay. Yes. Doobity boop ba boop. Okay, what's up here? So x3 equal -2, that thing, divided by 2, here. Nice one. Are we saying here, like, guys, are we saying with this shit, are we saying that the last row, sorry, the last column is B? Because if we are, then it makes sense. But if we're not, then it doesn't make any sense. But you understand what I mean here? Like if this little part here means that like we're using an augmented matrix, then that would make sense that we're doing this, but like that, this doesn't make sense. Because we're not doing it, like we're doing it here. I don't know if there's an error here. I don't know. Is there comments on this? Come on. Shit. Okay. Okay, right? But like what's up here? So then x2 is what? X2 is gonna be 3. Yeah, that one minus, this is our BK, minus 3. Oh wait, no, it's gonna be this one. 3 minus 3 times x3 that we just found it here. So 0. And then x1 will be 1 they could have chosen a better. Yeah, this is not good. Where do we have a 1 here? Y. Okay, 1 minus x3 minus 1 and x2 divided by 2. Okay, I think this 3 is there, and then this minus 3 is there, right? And then we divide by where we're at. We're always dividing by where we're at. and we're just not writing it here. Let's take a okay, and so and that's not exactly correct, or is it? Yes, because we're okay. Wait, I'm gonna take that. Okay, let's redo that. Thank God I'm not coding this, right? Okay, so okay, we have that here. So what's up? What is going on here? What do we have? We're starting like these. These here is where we land. Like we're landing here. Because the rest is all garbage. But like what? We're doing -2. So we're doing just this, right? Effectively. But we're not taking this into consideration. And the other one, we're taking this into consideration now, but before we're not. I feel like the actual pseudocode for this is not well written. It's my hunch. Because what I feel we're doing right now here, what we do, what the last one here, right? When we get there, yeah, well, what are we doing here? We're doing -2, and then we're doing nothing, and then we do divide by 2, which is that here, right? And then the second one, what we do? Second one here, we're doing 3, which is this one, right? And then we're doing one thing. We're doing minus, and then we're doing -3 times x3, this one, x3 that was found here, right? And then that's it. Then we divide this whole thing by 3, which is this little guy over there, right? And this one was this little guy over there. And then the next one, so this one, we're doing 1 minus, right? Minus, and then we're taking x3. So we're doing 1 times x3 that we already found, minus, and then we're taking that -1 here, so -1 times x2 that we just found, right? And then we're done here, and then we do divide by 2. See what I mean? Like, it doesn't seem to be the exact same algorithm that we're looking at here. It seems to be like a bit different. Like that thing and that thing for me is not the same thing. It's like formulaically not the same. So what are we doing? You see, we're starting from I think like that algorithm will make sense if we didn't have that, and this was k. No, I think that would make more sense, because in that case we're gonna like first shot, if we had that, we would just skip that completely. We're just not do it because there's nothing to do, right? And we're just gonna do that. And then the second shot, we're just gonna do once of these. We're gonna do 1 minus, and then we're gonna do the end, right? So minus 3 times that one, or what we found before, right? The BK we found before. So it would be x3, right? But that's it. We'll just do that. And then with this, we're gonna divide this by 3, right? Just right there, 3, which is gonna be a bit. No, yeah, it's right. Sorry, it will be 3 here, and there we that, which I feel is good, right? And then the third one, which is like the upper one, we're gonna do okay, give me 2 seconds. My wife is outside, locked in. Hi Faima. Okay, so what I was saying is, but then that doesn't, yeah, that makes sense. Okay, because this is starting to get bigger and bigger, and at the end, we go through the whole thing. But we don't touch the last one. I feel like this is the algorithm. That's the move, right? If we do it like this, I think we're gonna be good. I think the one is not right. Well, I mean, does it make a difference? It does, because it will just mess it up. Yeah, I think it will just mess it up. Okay. I'll go with this. I'll go with this, and we'll see what's up. Okay, perfect. So let's go. What's that? Okay. Oops. No, I wanted this. Okay. Perfect. So let's try to code it. So np0 like. Okay, so this is gonna be our solution vector x. X is gonna be that, and this was gonna be this. We used at the end during the backward substitution. Or no, yeah. We don't have to do that, no. No, actually, we don't. Okay, so we start here. We don't need to do any of this. We can start directly at this point. So we're gonna use the same thing for k in range 1 to number of rows, right? Actually, we can take that out. We can do num row equal a.shape 0 num call equal a.shape 1. So a variable initialization. So that's good. And then we have just gonna put that much larger. Sorry for that. Okay. We have the initialization here. So for k in range num row, right? That's what we're doing here, right? And then we're doing the pivoting. So do the pivoting, and then we do the rest. So the partial pivoting, I'm just gonna make another function here. Def partial pivoting, and I want to like, I'm gonna give it the matrix. I'm gonna give it like a k, right? And that's it. Like with this, it will be able to do the square thing that I need for the partial pivoting. And I will take the highest absolute value in this, find the highest absolute value in this chunk, and then swap the rows. That's kind of what I will need to do here. So I'll take the A, and I'll take a K, right? And then here, so find the highest absolute value from a range K from from row and starting at row call K in above. It will return that index, so that's it. So we're gonna do return highest index. Yeah, that's pretty much it. And this is like my coefficient matrix fully, and my param K current row slash call starting position, right? So that being said, what we're gonna do is for row, no, so for column in range A shape 1, right? But we start from K, right? We're doing like that, and then we just do that. So highest absolute IDX equal K at the moment, and then if A dot shape K call bigger than highest absolute oh, wait, A dot gonna be K at K, right? Absolute value, then highest I am not sure at all if this thing will work. Okay, let's just take it back from the top here. What the heck we're doing? So I need to find the absolute indices of largest value. Yeah, that's what I'm trying to do, right? And then our K is important because it will tell us like where we need to check, right? Because if you think about it, here we're gonna check this whole thing, But after that, we don't care about what's happening in the top. It's not important, right? Because like these don't change. So k equals 0, we're going to start from here to here. K equals 1, we're going to start from here to here. K equals 2, we're going to start from here to here. See, that's the motion I'm trying to get. And if we had like a super huge matrix, they will like be like a like shorter and shorter slice that we're going to be doing the checking in. So that's what I'm trying to get. So like right now I'm saying like the best value is like at that k. I'm assuming though that this is a square matrix. No, I'm not assuming. I think that's good. That's good enough, I think, right? Yeah, but it is assuming it's a square matrix though. I mean, yeah. So we're doing okay, and my IDX is like right now it's like at 0 or whatever, and then I'm gonna go from where I'm at until the end of the number of columns, and then I'm gonna go get that thing out at that k. The k doesn't change, right? For this column, sorry, at this row, and like that column. And I will check if this is bigger than the highest absolute value. If it is, then I will say like the highest absolute value is this, and then the highest absolute IDX is this. Then what I do, I'm gonna actually do the swapping. So I'm gonna do the partial pivoting here. Right? Highest absolute IDX. I'm gonna do that, and then I'm gonna do swapping. So get the IDX for do the swapping, and swapping. I think I found a pretty cool way to do it last time. Don't remember what it was. Give me 2 sec, because that was cool. Where is it? Reduce row echelon form. Yeah, this one. The swapping was this. Is it this one? I think so. Yeah. Yeah, it was this formulation, which I found pretty cool. So this was A, this is A, and then what we're doing effectively is we're taking, we're just swapping the two together. So we're taking this one, and here I can put like K there, and then take K there, and that will, whoops, here, that will just swap the two, right? If we have the exact same number, this will do nothing, and it's fine. I think it's good enough if it doesn't do anything. But yeah, at this point we should have a swapping done properly, right? So we swapped our stuff, and because of this, it will not kind of override what was done before, and we can do the rest. So the rest is what is this. So for I equal k plus 1, so for so here it's Gaussian elimination for the row, for the remaining rows, and it's going to be for I in range k to num row k plus 1. Right, so this is k plus 1, right? To number of row, yeah. We get the m equal, and it's gonna be a I k divided by a k k. Okay, divided by a k k, right? That's our m, and then we're going to use that m to do the transformation here. So for j equal, wow, we're starting at k. What? That's why? This one I don't get. What's up? Yeah, this part is weird. So partial pivoting, we did that, okay, and we swapped this one to the top, and then calculate the factor of the elimination for A12. So that would be that, right, for this one, M. But we don't start at k, we start at k plus 1. We're not eliminating 5. I think there's some like issue in how it's written. Yeah, because we're eliminating the thing below. We're not doing just the k one here. Okay, anyway, so we're gonna work with what we have. So for j in range k plus 1 num column right a I j equal a I j minus m. Wait. No, we still use the same m times a k j. Yes. What we're doing here? Well, we have k. K at j. Whoa. No, I think it's good. No, I think it's fine. I think it's all good. Oh, no. Wait. No, I'm just stupid. Because this, we need to go through the column like this. Okay, yeah. Okay, cool. Sorry. I just had a brain fart here. This is fine. Because this is modifying every element in the row. Right? We're modifying the whole thing. So from the beginning, if we're at the beginning, to the end, right? But then we're always taking a square because there's no point in modifying wait, what? Yeah, well, there's no point in modifying the zeros. We're just going to a small square. I'm getting confused because usually you will do that in NumPy straight up, which is like a you're not gonna do like element by element. You're just gonna multiply the whole row. We're gonna do it this way. It's fine. So that's that, and then we just change the b. So then we modify the b. And we're doing this the same way. Bi. So b at I equal b at I minus m I k. No, sorry, this is not matrix, just m time b at k. Right. Right. Makes sense. Okay, cool. Okay, cool. Guess that's it. So this is the whole Gaussian elimination step. Right, we're doing that now. So this is step 1. Gaussian elimination. Okay, so then at this point in time, we should have proper B's. Step 2 now is like back, how do you call this? Backward substitution. Backward substitution. And that's the thing. This is this algorithm we're gonna try to wrangle with. My hunch is that I don't think I'm gonna get it right. Yeah. So okay. So for k in range, and then we're gonna go num row, num column. No, num row, sorry. Num row to 0, right? We're gonna go this way to -1, I think. So we're gonna go in reverse order, and then we're gonna go for I in range. Number of columns, num column to k. I do think this is what we're gonna do. And we're gonna do b equal, no, I have to be careful here, bk equal b at k, right? And we're gonna do b at k equal b at k minus, and we're gonna do that stuff, right? A at k I times b at I. Right, and then we're going to do b k equal b at k divided a k. Just now I'm thinking of it like this will not work. If you take a look here, yeah, that thing is going to be messed up. So I'll just need to accumulate them over here. I don't need to initialize anything. That should be good enough. Okay. You think it's going to work? No way. No way this thing isn't going to work first time. Return what? Is this it? Is this like my B? Are my B's what I'm supposed to return here? Well, because if I backward substitute, should give me my my X solution. Okay, let's save that. Let's see. For sure we're gonna hit a bunch of syntax error. Where do we get that? So we have int object is not subscriptable. Okay, I made some error somewhere. Okay, now call first off what? So everywhere. Okay, this should be good. For k num row, there's an int somewhere that I messed up. Okay, this is good. This is good. Is this here? I get that shape. K A A K A K A K K. Okay. This should seems fine. For I in range, a k plus 1. Okay, that seems to be good. Is the B, what is the B? No, the B is good. Maybe it's here. I don't see where. Okay, wait. Let's good old debugging start, and then we're gonna do so. This is gonna be backward sub. And then we're gonna do, this is gonna be Gaussian elimination. Do that here. Usually I will be a bit more sophisticated in my debugging, but unfortunately, like, it doesn't tell you exactly where it's messing up. So it's not too helpful here. So here, I'm gonna put a K. Okay, let's test it out. I'm not getting absolutely no input, no output here whatsoever. I'm not even starting. Is this it? What the heck is going on? What? Oh, I hate this. I hate this so much. Okay, I don't even know where. It's not the best, to be honest. Okay, let's remove that part. Still the same int error. I'm not sure what is going on. Okay, let's comment this out. So if we're to debug, don't debug like this. It's the worst type of debugging. But I'm just doing some bunch of scientific. Okay, we're there. That's good, right? We did initialize, and then we're doing the step 1, right? Oops. We're doing step 1. So for k, numero, and then we're doing this. Are we doing that? Yes, perfect. So then if we do this and that, is this good enough? Ah, okay. So is this, where is the problem? It's in there somewhere. Okay, so what's up? Is it this? You're gonna find out. Okay, so it's somewhere here. There's just to pass. I almost feel like a compiler or something. But that's good. So if a that you see, this is the issue. Doop. Okay, that's it. Just this, that's the problem. Okay, cool. That should be good. Yes, we're doing Gaussian Elimination stuff. And then can we swap? Yeah, we're swapping stuff. And then can we do that part without breaking? Right? Seems like it. This is good. So we're out of here. We're out of here. Now we just need to do the backward substitution. And return B. We haven't got the right answer though, but we're getting there actually. Okay, this is that. This one, okay, absolutely not the right answers, and this one also is all messed up. Okay, but we're getting there. That's the good news is that. So if I actually print A, do we have a triangular matrix? Okay, we have that. This looks triangular, right? That's too big for me. That's triangular also. So it's like, seems like we're doing the right stuff here, right? Now, this is not good. It's really not good because it's doing nothing. It doesn't do anything. We're not even going here. Right, because otherwise it would have printed backward sub, but it's not doing that, so it's actually not working. Actually, I'm gonna move myself a bit up for the debugging just so you can see. It's not printing this because I'm not doing this stuff properly. Can we do reverse range in reverse Python? Okay, wait. I can use a negative step, I guess. Okay, yeah, I can do that. So we start at what? Start at 0 until numero, and then we do -1. Is that it? That's good. Will it do? Will it do that? No, it's not doing it. Oh no, sorry. Yeah. So 0 is here, and then that. Then we have a -1. So 3. Sorry, -1. So we do 2, 1. I just wanted a 2, 1, -1, 0. Okay. This is not good. And what's up? So 2, 1, 0. Good. But we're not getting the right we're not getting the right answer here. Okay, wait. Oh wait. Oh, this we're doing fine. It's that part that is all messed up. BK. KY. Well, I think I'm doing the same mistake here. Num column to K. We're doing it. Oh, yeah, this one is. Yeah, this is this. What's flow I'm trying to do here? Trying to do tac. So that doesn't work. Right, I have to do the same thing. I have to do num of column -1 until we do we hit K, non-inclusive. Right. Otherwise we're not gonna do that. Okay, well that's good. So here we have that, and then we have here container. So first one we're doing nothing, and then this one we're doing 2, and that's it. And the second one we're doing 0. Well, the second one we're doing 2 and 1. But that feel reasonable. I don't get why it's not working. Oh, but this is good. No, I think we got it. This one is good, and then this one's not good. But this one was good, actually. I didn't mess it up. No, it's fine. And this one is it fine? No, this one is not good at all. Well, we're not crazy far either. But that's not good, no. Yeah, I feel like this part is slightly messed up. There's something that I'm not doing properly, and I think it has to do with like me not understanding this literal algorithm over here. We start at the last row, right? So we start at the last row. That's what we're doing here. This is my K. Okay, if I start at the last row, I'm here, and I want to skip this whole thing. So that's what I did. I skipped this whole thing, and I'm gonna do -2 divided by 2, right? Well, the first one then, no, I should have it correctly. Yeah, well, this is bizarre. Okay, we just print that. We're gonna get there. Okay, so these are my number. Okay, here. So what do I work with? 2, 5, 1, 0, 3, 3, 0, 0, -3. Right, and then I have at this point 2, 3, -3. So this is my A, this is my B. What's the answer? It's 11. It's 11, the answer. Okay. If it's 11, the answer, and I'm going to do -3 divided by -3. This doesn't work. What the fuck? Makes no sense. No, this is not good. What are we starting with? We're starting by 2, 8, 4, 2, 5, 1, 4, 10, -10. What the heck? I think there's a swapping at some point I'm doing that is garbage. But why? so high. I should not have 251 at the top, right? At the top I should have 410 minus 1 because I should have swapped that. Am I swapping? I don't think it's top notch either. I have my A and my K here. It should be 0 at the start. For colon range is 0 to number of column. Yo, no, it's in the rows direction that I'm trying to do this. And it's in the row direction. I'm trying to do that. No, it's good. No, yeah, wait. I'm trying to stay at the same column. I'm trying to stay at the same column and modify the row index. That, like, I'm trying to move like this, not like that. So my columns stay the same and then my row is moving. And if my row is moving, then it means that this is this, and then this is K, and that's that. And this is row I. So at least now I should not have like 251 at the top. Should have like 410 something. Yeah, 410 minus 1. Okay. That's good. I got this one there. And I have 0 0.3, 0, 3, 4.5, and then 0, 0, 1.5. And it give me 240, which is not that. It's good. It's still not good. This is still messed up. Yeah, we're converging, folks. Like we're going there. Okay, so 410 minus 1. This one is fine, right? And then I'm eliminating these twos. Am I doing it correctly though? Am I eliminating them properly? The swapping, I think, is fine, right? I think that's working relatively well. And then, like, this whole portion here, this portion, I think, is a bit garbage. What is going on? We get the M here. Because I'm saying it's a bit garbage because we're ended up with like 1.5, right? And our B is what? Our B is literally 0, right? So it can't be 0. If it's 0, then it doesn't make any sense. We're supposed to end up with 3.0. So something is off on this front. So our M right now is what? It's IK divided by KK. IK. Okay, that seems reasonable here, right? So it doesn't seem that we're doing something weird. And then for J equal K, 2 number of columns. J in range K, 2 number of columns. I have a feeling this is where it's getting funky a bit. So we're in this row and then we're modifying each of the element. So we're doing we're skipping one. We're skipping like the column, the K column that we're at, and now we're doing what we had previously, ij minus m times kj. So the previous row, now we're moving into that. Okay, that seems good. Is it the B that is messed up? No, that one also is good. Is this another one that we haven't swapped properly? I don't think so. Okay, 4, 10, minus 1. That's good. And then we have a 0, 3, 4.5. Both of them are 0, 0. Am I printing the right stuff? Yes. I think the issue is not on the backward substitution step, right? It has to be prior because, okay, what we have right now is what? For some reason, I always get stuck. There was not once where I did it one shot. Well, no, not true. I did it once, one shot. But it's not even like, doesn't have any correlation with the difficulty of the actual thing. It's just like, there's, for some reason, some algorithm, it just doesn't compute for me. Okay, so we have that, right? And then we have 0, 3, 4.5. And then we have 0, 0, 1.5. And then our B at this point is 2, 4, 0. What do we start with even? We'd start with 2, 5, 1. And then we get 2, 5, 1, and we have these ones. Okay. 1.5. All right, cool. So like that is clearly 0, right? Just like the x3 need to be 0, but that's not the solution. So the solution is 3. So for sure, the problem lies above. And like all the other ones are also messed up. Well, yes, the middle one also is messed up. This one's also messed up. Yeah, that's not computing well here. Okay. I am not gonna get that hint. I am not gonna get it. Okay, the shape I think is good. I think this part is also fine. I feel like this is the, oh wait, no, maybe this is messed up. Maybe it's this part. It's always a square matrix, right? I think it's always a square matrix that we're working with. 3, 3, 3, yes. So it's never, okay, it's always a square matrix, so that's good. And I'm taking the top left of that square matrix, always, as the highest absolute value. And we're gonna, that we're taking. And I'm iterating over the row. And I'm checking. Oh, wait. Is this it? No, it shouldn't matter. No, it shouldn't matter yet. Because I'm just taking the largest value here. And I'm taking the row I. Okay. I'm taking this bigger. Okay, and I'm just returning the IDX. What is it saying? Partial pivoting looks at all the other rows in the current column to find the row with the highest absolute value. This row is then interchanged with the current row. This will not only increase the numerical stability of the solution, but also reduce round-off error caused by dividing by small entries. I mean, at the end of the day, it doesn't matter. It shouldn't, like, this should not, that's it, like, it, which absolutely doesn't change anything. We could just not do that and it will still, like, give us the right, the right values. I think it's like something here. We're not scaling properly. For I equal k plus 1, two numbers of rows. And here we're doing numbers of rows minus 1. Why? We're not doing the last one. What? Why are we not doing the last one? Is this it? Is it just that? We're just left the last one untouched? It should not be that. What do we have? 4, 10, minus 1, 0, 3. No, it doesn't, it shouldn't change anything here. Because anyway, like, no, I don't think it's that. It will not change a thing. And on this front, oh, because we're not, like, we're not gonna even go there. This is fine. Then we do get k plus 1, two number of rows. Alright, guys, we're gonna have to print stuff here. Highest absolute dx. Print. And okay. Really, I have to improve my debugging game. Right now I'm not that sharp. Okay, so 0 and it says 2. This should make sense. Then 1 and then we're saying 2 still. So wait, I'll need to print it. Old point, I'm gonna print A. Okay, it's gonna be a mess to read though, right? So what are we saying? We're saying that, so we're here, right? We're at row 0, and we're saying that the highest absolute IDX is 4. Good. And then we're at 1. So we're there, technically speaking. And highest absolute IDX we're saying is at 2. Which is 3. Wait, right. We're here at this 0, and then we're doing that. Okay, and then we swap them. And then we say here, yeah, it's already pretty messed up. So we're saying that here, right? We didn't swap, did we swap them? Yeah, we swapped them, okay. We're saying we're at current K2, and the absolute IDX is 2. And then we just exit. We just did one manipulation in this whole thing. Just one manipulation, and that killed off this one completely, one shot. Why? I think the swapping is fine, right? If you print A before, A after, it's gonna be very ugly. But it should be fine, right? So here, yeah, and then we swap them. And did we swap them properly? Yeah, the swapping is good. And then here we're saying, here to here, we're swapping that one for that one. Swap, 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 swap. And then here we're saying, it doesn't matter, so we're not swapping anything. Okay, so we can confidently say that the swapping is not the issue on this front. So that's not the problem. So this whole part I think is fine. My issue is here. Right where we're doing those manipulations. We're getting to an A that is a bit weird. The first shot we're doing, like when we're like modifying this one, we're getting to some weird territories. Right. Is it has to do with how we're traversing this maybe? This is a row, this is a column, so we're doing one row below, but we're staying within this column. And then we divide them by the current element, KK, yeah. Yo, if anybody has some idea, we're too deep right now, guys. The fuck? What are we saying? And this should be straightforward. Like, why the heck am I still there? Why? Like, this doesn't change. This is fine. The J is the one that is moving. Right. Right. G, A range, and K. K number column. What is going on? And then we're supposed to kill them off one by one. Like, this is not supposed to be something outrageous here, right? Like, these M's will not be like absolutely crazy bonkers. We have a 0. Why do we have a 0? 0.5, 0.5, 0.0. Oh, wait. Okay, that might be it. For sure, if we have a 0. Okay, so what do we have? We have 2.0, 4.0, 2.0, 4.0, and 0.0, 3.0. But what? How can we have that? Okay, wait. Okay, so we have 4, 2, 2. 4, 2, 2. And we iterate on the row. So the 4 stays. Yeah, the 4 is fine, 4 is fine. So I have 2, 4, 2, 4. And you 0 out the... Okay, yeah, that's good. You 0 out the whole thing. So that's one is good. And then we have... I didn't have like what? I'm working with 3 and 0. Yeah, which makes sense. Yeah, it should like that. I don't like this. This part is not. It's not crazy. But if I have a 0, it will 0. It's already zeroed out. That part. After the first thing I'm doing here, this thing is zeroed out. Like. But it's not this part that is, it's this other one. But I have a 2 and I have a 8. Okay, so what? And then I'll print that. So we have 2, 4, 0.5. And then we have 2, 4, 0.5 again. Because it's both 2's. So this is the same thing, which is fine. And then what the okay, yeah, that's that. And what's going on here, right? So I have my I want to know what's going on with my eye here, after, before and after, right? So this is before. I swear, if this is like the test case that is messed up, I don't think I'm gonna recover from this. Mo, if you're there, let me know. Mo is the one that like made the website. Let me know if this one is messed up, or if I'm like just not that good at doing it right now. Okay, before and after, it's 2, 5. It's this one that is getting canceled out. Yeah, okay. Does it make sense? Does it make sense that it is getting killed up like this? Okay, I'm gonna just throw this to Wolfram Alpha. This is for a sanity check here, folks. Just give me 2 seconds. Okay, so wait. Fine. So the system of linear equation A is this, and B is that. Just double checking. I'm not saying that like I'm not correct. I'm literally just double checking. Okay, wait. 4, 2, 5, 1, 4, 10, minus 1. Wait a second. Okay, cool. Okay, so that seems fine. Like the actual answer seems fine. Right. I think it's just me that is not understanding the algorithm properly. To the right, okay. The entry is a need on 0 row. Okay, wait a second. This is not row echelon form. This is reduced row echelon form they're talking about. Okay, jeez. Wait. I think the algorithm is just completely messed up at the moment. That's not it. Replace metric with the row echelon form metric, which can be more easily solved via backward substitution. Leading entry in any non-zero row is 1, and all entry below it is the same column as 0. Okay, blah blah. Like that whole thing is not that. Like like you see, this is what I'm doing right now, right? Like this is literally, this is it. Like I'm doing this one. 2, 5, 4. Apply partial pivoting to increase the magnitude of the pivot. What are we saying? They're not swapping the rows. Am I no, I think, wait, 2, 8, 4, 5, 5, 1. 2, 8, 4, 2, 5, 1. Like, you know, it's not the same thing. Okay, so okay, that's good. It's not the same because otherwise you should have swapped the 4 and then so they're swapping 5, 5, 1 to the top. I'm doing this. This is all fine. And then they're saying they're doing 1, 2, which is a 2 here, divided by 5, 0.4. Apply the scaling to row 1 and subtract this from row 2. Right. But you see this 284 is one that give me a 0 here too. Get a 0 on the B's. Okay, wait. I'm gonna just do it. I'm gonna do a little hack here, right? Stay with me. What we're going to do, I'm just gonna substitute the 2 here, right? I'm gonna do this. I'm gonna do a at 1 1 equal 5, right? Print a. This should give me like the same thing, so I could just walk through it to see if I'm being dumb. Okay, cool. No, it didn't change anything. Oh, sorry, yeah. 0. What? Should give me a 551. No, it didn't change anything. What the fuck? What? 2825. What? Okay, wait a second. What's going on? Because I didn't save. Okay, wait. That's just weird. Two, 5, 4, 2, 5, 1. Oh. Wait, what? Okay, right. 1 and 0, sorry. We're staying at row 1, column 0. Okay, 551. This is it. Okay, guys, we get it. So this is the exact same thing as what they have, right? Like that's the same thing. Exactly the same thing. So now we can step through it and see exactly where we're fucking this up. Because the x3 should be minus 0.66 and we don't have that. Okay, cool. This is good. Okay, so I'm doing the backward sub like this. This is it. And what is my A and B at this last step? I don't need to print A right now. Fine. Okay, that's the first one. Okay, this is good. I know that. I just did this for debugging purposes. If you're stuck like this, just use the hints. There's hints in there that can get you on track, but I refuse to do it. Okay, 551063600 minus 5.4. This is right. We got it right. Like that's fine. Right? Like this is not crazy. The B's are all messed up. You see that? We didn't swap the B's. Good Lord. Of course, everything is messed up if you keep the... if you change the order of everything. But you... yeah, man, like this is... oh my god. There we go. You have to swap both. That should fix some of the problem, I think. Wait, no. Invalid syntax. Okay, what's up? What did I do wrong here? Oh, I didn't put an equal. Okay. Okay, so wait. 5, 0, and -3, right? 5, 0, yes. And then we have -66. I have a positive. It's not there yet. Why do I have a positive here? If this is a negative. Is it negative? Yes, -5.4. I have a -3 here. Why here it's a 3. So I have 5, 0, -3. It should not be a minus. Is it the way that I'm doing my... my B's don't look that messed up. -1, 251, 284. Okay, so the numbers are all the same. So I get 551, 6, 3.6, 0, 0, -5.4. And then I have 5, 0, and I have a -3 here where I should have a 3. Why do I have a -3? Yeah, why do I have that? My M is like that. My B is equal to I. Yeah, that should be fine. There doesn't seem to be any issue in the... oh, is it because of the absolute thing? No. Wait, what is? What are they saying? Okay. Where's the magnitude of the pivot? Okay, that. Subtract from row 2 after the full Gaussian process has been applied to a... but I have 5, 0. Okay, yeah, folks, like we're getting there, right? Stay with me. Or like here, the issue is that we have 5, 0, -3. Is this... no, this will be messed up in all of them. But like we have 5, 0, -3 in the B's. At this point, we should have 5, 0, 3. I can't trust myself over here. I'm not sure if I'm right or if they're right. Yeah, I'm not sure why I'm having that. The main issue we had is we didn't swap the B's at the same time because we didn't have an augmented matrix. We just had that. And at this point, is it because of that? Like literally because we're going through the last row? It shouldn't be. No, it shouldn't be at all because no, that's not the issue. The formulation is not the same, but it should be correct. Yeah, it should be correct. Then we go for k plus 1, number of rows. Everything is fine but that. I wonder if, like, okay, let me just go ahead and double check, right? Double check with the and b equal 2251. Okay, I'm just on Wolfram Alpha right now, trying to get some just double checking. Okay, wait. No, I get a -3. I get 1. No, wait. No, I get a -3 here. Okay, wait. So 5 divided by 9 is what? No, I think this is wrong. Like that. Okay. Let's kill this off and see if we're getting closer, because I think my algorithm is somewhat correct. Oh, jeez. Okay, guys, we got it. Is that it? That's it? We got it? I was right all along? Well, actually not all along. Okay, so what just happened here? This example is actually wrong. This is not the right thing. Here it should end at -3, right? So there's a slight typo over there. It's fine because when you look at the actual implementation, the only issue I had, right, since the backward thing that I did was flawless, right? Perfect. The only issue I had was I was actually doing the swapping in I was doing the swapping right? I had one mistake where I was doing the swapping on the column instead of the rows. Fixed that. But after that, I was swapping the A's but not the B's, right? So what happened is that you get this, right? You have your matrix here, and you have your B's matrix, and these are kind of connected, right? Like it's not the same element, but they're connected. Like you could jam them all together into like an augmented matrix and be done with it. But like we didn't have that. We're not doing it like this. So when I was actually swapping these together, right? And let's say this goes like this, and then this goes like that, right? You can take a better color. Goes like that. What happened was that after this swap, I had this at the top and this at the bottom, right? And then nothing make any sense. Like nothing will make sense because the green row is now with the purple row, and like that's at this point you broke completely like the dependency between like the matrix A and the vector B. So you actually have to swap them also, right? If you don't swap them, everything is messed up, which is this part that I completely brain farted on. That was good, but like I was right. It's up to k. You cannot do it up to 1. So yeah, that's it. Any question? I'm pretty proud of this one. I think I did it right. So I'm just gonna clean it up a bit, save it, so that I'm gonna use it at some point for, I think, another exercise. We need that too. We remove that. Deep. Do the swapping on both A and B, and that's that. It's clean, pretty clean, not too bad. All right, cool, perfect. Save that code, please. Okay. And I think that's it for today. Honestly, I was planning to do the other one, the AutoGrad run, but guys, it took me what? It's been how long? It took me 2 hours and 30 minutes to be done with just this first one. So which one is it? Gaussian Elimination. I'm gonna take that and put it into here and say it's a yellow. Had a lot of trouble actually with the swapping. Made everything else super complicated. Right, okay, that's it. I think I'm gonna redo it again sometime, but not today. Yeah, we'll do the AutoGrad one another time. I think that's enough for today. So that's it. I hope this was useful, folks. Don't hesitate if you have any more questions, you can DM me and just chat with me on Discord. And I wish you all a great rest of